Hello everyone, welcome to Tech Sapphire. In today's video, we'll go through some SQL essential which is required for performance tuning, and these are very basic things. So some of them will scale from basic to little bit of intermediary of SQL developer course, but these things are also required for any SQL developer to do two things. One is optimize existing query. The second thing is whether they can read the existing code. A lot of time what happens is developer lacks in just reading a big stored procedure and forget about the optimization of them. So unless you know how each of these operator works, you cannot be able to understand complete you can say a big stored procedure or complex stored procedure code. Also, I will tell you which of these topics are used in which kind of environment. Give an example: global temporary tables. So when you are working on some code, you will might find a global temporary table. So now let's assume you don't have conversation with the actual developers and all. So what will happen, you can assume why they might have used just by looking at it. So in today's course, I will cover up some basic to intermediate or some advanced topics for SQL developers, but these are definitely important for all the people who deals with optimization or looking at someone else code, or you can say who are doing code review. And some of these are also important from the interview standpoint. So if you are going for a SQL developer or data engineer interview, so this question might help you. So first we'll start with some very basic essential like the variables. In SQL Server, variables plays an important role because if let's say you are troubleshooting an issue in an existing query, or you are a BI developer who is working on some reports or analytics dashboards, and you are struggling with some data, the first thing is, can you run your script and parameterize it? So the variables are very simple thing. So I have just covered a small example where I'm just setting up an order ID and just running on an order table. For this demo, I'm using Northwind database. So let me run it. I think it has got disconnected. And Northwind database, let me just use Northwind here. Use Northwind. Northwind database is a free database available on Google. You can find it. Some of the tables are not, but for those I have added the script within the you can say this particular script. This script you will find under the description of the video, and you can download from there or from my website. Okay, coming back to our basic you can say example of an variable. So here I'm setting up an order ID, setting up a value, and just running it as a parameter on the below query. Now why this is important, because let's assume this is not a small one-liner query, it's 100-line query, and there is a filter. So now you want to rerun the query multiple times, but and you want to test why some data has not gone into the system or something. So what you can do is you can easily do it by creating an variables and passing those values in the variable and ensuring all the data is coming as per that variable, and you will be able to troubleshoot why that query is you can say behaving in that way or missing out some orders. So you can do that. Let's say there are 100 of joins, you can replace one of the inner join with left join and see where the data is not coming from. So it becomes easier when you parameterize it. Now the next one is table variables. These are again very simple, but from the performance standpoint of view, I will tell you how they are different from the temporary tables. So table variables are nothing but they are in-memory object where you can define a table structure. Now with table structure you get primary key, foreign key, and small indexes also you can particularly create. But the problem with table variables is they are in-memory tables, means everything is in memory. If something goes wrong, or let's say you want to share the same data to another query, this will not work. So if I run this query now, this table variable doesn't exist. So the scope is very limited. But let's assume you want to do the same thing, you can use temporary tables. Now in temporary tables, if I run the same query, I'm pulling some 5 top orders, adding in temporary tables. Now the temporary tables I need not to recreate again and again, because if I try to, it will throw an error because it already exists. So temporary tables are session level. So if I run in this particular session, it will work. But let's go to another window. Let me connect it again. So this table doesn't exist. The scope of this temporary table is only till this particular query window. So when you are using temporary table, the scope matters. So within that particular scope, you can reuse this table. Now there is one more difference when it comes to execution plan. Okay. Now I will run the same query along with the table variable, and we will see the execution plan of that particular query compared to a temporary table, sorry. So if I go into my execution plan, the initial one are just for pulling the data and all. Now, if let me just move this window here. Okay. So now let's assume this is my execution plan for select star from @temp orders. And if I take my focus here, you have to read one line within this particular pop-up, that is estimated number of rows for all execution is 1, though the output is 5 rows. It is expecting us to, from the execution plan side, it is saying it will only return 1 row. But when I go to my table, temporary table, then I see here the estimated number of rows for all execution is 5, which is the actual one, which actually the result came up. Let me just move it up. So here we have both output. Now, where this play a significant role when it comes to performance optimization. If you are using SQL Server 2017 onwards and the dynamic execution plans are kind of enabled, then this will not, you will not face much performance problem, because what it do is it remember what was the last number of rows coming from that table, and from that particular it will create the new execution plan, or you can say use the existing execution plan with that value, and a lot of memory will be given to the same query. But the temporary table will always act in the same manner. Means whenever the table are created, the table statistics are created, and the query plan will have more memory based on the number of records in the temporary table. So when it is optimization, especially before 2017 onwards, 2016, 2014, those kind of SQL Server, in that you have to always remember, you always use temporary table over the table variables. But on 2017 onwards also there is a problem. Not all DB enable that option. So it's always better to use temporary table when the data is more, and when the data is very less, like say 2 or 3 records, like a gender or some type of data you are just caching out, then you can use the table variables. Now coming toward the next concept, which is global temporary tables. Now as we discussed, the scope of that temporary table remain in that particular window, not in this one. But let's assume you want a global scope temporary table, so you can use double hash with that. Now once I create it, this particular table will remain and able to access in other memory, other you can say sessions also. Exactly, they will work in the same manner as the temporary tables, means the execution plan remains good and all. But now the question is where you use this global temporary tables. From my past experience, I have worked with many organizations where there are a lot of reporting platforms. These generally are used by the team in the reporting environment, where they are running some extracts or ETL jobs or reports at the end of the day or by end of the week, and then they have to cache some data. Now every query will require that same data, so you can move that to global temporary table, so that when the report process is going on, all the table has access to this particular table. Now these are very essential thing. So now we will turn toward little bit of more SQL query writing videos, where like other concepts like CT we will start with. Now this is very important, because if you are managing any existing code and a lot of long queries are written, you will see CT everywhere. And especially they are also used for recursive queries. Means let's assume you have an hierarchy table where one person is a manager of another, and you want to find out all the subchilds and all. So you cannot do with the normal functions like we have in other programming language. So you have to do with, you can say, recursive CT. So we will cover that as well. So CT is nothing but it is storing the output of this, you can say, query for the execution in this particular session. Means this query is not accessible even in the next, so this CT is not accessible in the even next execution. It is only available till this particular execution. Now CTE are temporary, they are actually nothing but the sub query. So if I copy this query and add it here and select it, this is exactly the CT. So instead of having a complex sub query ingested, or you can say infested a big long query, you can easily use CT to simplify your logic, and it's always easier to, you can say, optimize, or you can say write down this one. This doesn't have any impact on your execution plan in general unless it's recursive one. So it just embeds this, but the only thing is it makes it look little bit simpler and easy to understand. So now coming to the recursive CT. Now the questions which I am, like the query I am about to cover, these are also some interview questions. Like say if you are going for a SQL developer, they might ask this particular question. So let's assume you have to generate rows you can or values from 1 to 100 but without a loop. Now here the recursive CTE comes. So here what I've done is I just declare two variables, one is start and end, and I can just do this also, select and then start, so that we can see what is the value in there. So it's 1 to 100. Now in recursive CTE the concept is very simple. It's 3 steps. First is seed. There should be a start point within the CTE. So here I'm saying select 1 as a number. So I'm starting with one row with a value 1. Then I'm saying union all. So seed will be always followed up by union all. You cannot even use union. It's always union all. So once you use union all, then you are writing a query, select number from numbers. Now number is CTE itself. Means after the seed going to the CTE, it is again querying back from the CTE, adding 1 to it. Means let's say start is 1, then next number is 2. But till what point? So the basic concept of recursion is the function should call itself unless a certain criteria is met. So this is the criteria. So this is like breaking statement. So once you have written this, your whole CTE is ready for recursion. So let me just run it. So here you will see. Okay, so sometimes when you are running, CTE requires to be the top query. So I'm just adding a semicolon so that the previous query ends before it. Now let's run it. So here you will see it has generated number from 1 to 100. It's very simple. First we provided 1 as a seed. We unioned it all with the same CTE where the number has went and with a breaking condition. This is the whole definition of recursive CTE. If you remember these 3 things, if there is any issue where the recursion is going above maximum recursion and all, you can easily figure it out, okay, where it might have going wrong. So either this break condition is not getting met and it is keep on going further and further, or there is a circular reference. So circular reference can also break the recursions. Now we just don't do that with numbers, we can do it with the dates also. Now this is one of the easiest example. Let's assume you are creating an analytical dashboard and you require at least one record for each date. Let's assume we are making a dashboard where we are showing what is the number of orders placed by a customer on one particular date, and it's a week chart. Now every customer is expected to have first, second, third, fourth, all the dates, unless else the graph will not be in a proper symmetry, because let's assume you have received the 10 orders on the first, and then second of the month we haven't received any order, third we have received 10 more orders, and the fourth is again we haven't received any orders. But here the count is 0, so the line should be coming from like 10 0 10 rather than 10 10, because if only 2 dates are mentioned, so I have to also mention the dates which are missing from his data set. So how we generally do is we create all the range of you can say dates, and then join it with the customers and count and manipulate the query. We will cover up that example later on, but in this one I have a start date which is 1st of 2025, and then I'm saying till 10th I need to generate. I am using again seed function. So first is the seed, let me just put a comment, and then follow up by union on, and then breaking condition. And here what I'm doing is I'm saying after this date add 1 day to it. It's similar to 1 plus 1, what like number plus 1 we were doing. So if I run it, I will be able to generate all the dates from top to beginning. Recursive CTE, people think it's very complex. If you define the things into 3 things, whether you have a seed or not, whether you have a follow-up union all or not, and then you have breaking condition. If something is going wrong, the breaking condition is not getting met, or you might not have incremented this you can say seed, so condition will not met. So these are very simple things. Okay, now coming to a complex CTE one. So I created this hierarchy table, it's already there, so I don't need to create, but you can create. Now what this hierarchy table has, it has an ID which is just auto increment, then employee ID, what is the ID given to that person, and the parent ID, and the description. The description tells what is the name and so on about the employee. Now I have this only 4 columns. Okay, now let's see what kind of data I have. So let's take the first 3 records. In this one, I have added 1, 2, 3 employee ID, but the parent ID is 0. These will act as my seed, because I tell na, like there has to be seed, because when I'm searching for any hierarchy, I will start from the parent. So here we have like parent ID 0. That means these are the ancestors, means from the where the hierarchy starts. And then we have like 4, 5, 6, which are saying like they are the child of 2. 2 is nothing but Ron. So these 2 records are of child of Ron. 4 and 5. 6 is child of 1, which is Yogi. So 6 is child of Yogi, and so on. So now let's assume you are writing the query where you have to fetch complete hierarchy. So we need to remember 3 things: seed, follow up, and the breaking condition. So let's see an example. So this is this particular table. These are the 2 columns which we will be, you can say, doing operation, because employee ID matters and the parent ID, because employee ID of parent is the parent ID of child. That is the simple logic. Now here what I'm doing is, so let me just run this particular query. This is nothing but the same thing whatever I require for generating my output. So I selected the employee ID, parent ID, I just rename the columns, and the parent description and the self description. Now parent I got. Now with the normal join you will get the adjacent parent. So that's what we are doing. So here we are joining hierarchy with itself, but here we are saying employee ID is a parent ID of the other. So find me the child where the parent ID is 2, let's assume. So these are the 2 records, Ron, like Jazz and Rat. Their parent is the Ron. It's very simple. Now let's see a bigger, you can say, complex query. So let's see the recursive one. So first is the seed. As I told you, my parent will act like a seed. And how I identify the parent? By knowing their parent ID is 0, means they are at the root level. So you always need to remember before starting the recursive, who is the seed. If the seed is wrong, then everything is wrong. Follow up by seed, then follow up by union up all, and then the breaking condition. Okay, so what my breaking condition is here, let me just move this one on the top. My breaking condition here all automatically bets by the join. There is no where condition here. Okay, now the main thing is I said find me the employees where parent ID is equal to their employee ID, means the parent is Ron, find me the child of it. And this should keep on going till the time you met the child who are not parent of anyone. So means there is no further hierarchy. So without even the where condition, this join act like that. And what I'm doing is here I'm just creating the level in a binary. Let me just show you the output. So these levels are created in binary. It might be little complex, so I have created this particular query where you will visualize it what level means. So here I'm maintaining, okay, this is the parent, so the parent ID is 1, level is the 1, and then Tom is the child of Yogi, because Tom parent ID will be 1, then 1/6, so 6 is the ID of Tom. So by this way I can find who is the parent and grandparent of any record, and this is nothing but the level information. This is level 1, this is level 2, like root level when I'm talking about. So here if you will see, if I say Doraemon is child of 10. Now who is 10? Mickey, and Mickey is child of 3. So let's say find Mickey, and the parent is Don. So Don, Mickey, Doraemon. So this is a hierarchy of it. So if you will see, so this is a recursion is very simple. First we find the seed, again act the seed, and who is the seed? Where the parent ID is 0. And then we have follow up. Let me just add comment out there. I will share this script, so don't worry. And then breaking condition. Now this is the breaking condition here, because automatically if there is no record where the parent ID of child, like employee ID of child is a parent ID of someone else, it will automatically break. So it's like breaking condition. Okay, and CT are very common. You will find them everywhere when it comes to existing code. So it's always good to know this concept, and you should be able to play around with it. And then I have created some triggers, and now these triggers are for showing you the magic tables. There are 2 tables called as inserted and deleted, which are always exist in the, you can say, triggers. Now, or you can use them without the triggers also, that also I will show. Now what is this magic table? Let's assume you have So we have one function called scope identity, where if any table is incremented by one, we can get that incremented ID for that particular table using scope identity, or you can say identity, fetch identity with that. Now the problem with that is, let's assume it only fetch the ID, but your requirement is when the data is getting inserted, there might be some transformation in data because of functions. You should fetch the original record, complete record. Now instead of getting the ID first and then querying back to the table again what is the data inserted, you can just write a trigger, and with that you can say select star, like you can say from the table. Why I've done the star? Because there are some data types in category table which are not friendly to you can say these tables. One is like binary and one is image and text, so few data types. So I've just added these two columns. So I have already created, so let me just add alter so that it can add it again if it won't break at least. And same way I have added for update. Now this is for inserted, when the data is getting inserted. But let's say updated. Now updated has a two cases. One is new data and what is the old data. Let's assume you are changing the category name to something else. Now when you are changing some category name to something else, automatically what will happen, the old name become the deleted value and new name become the inserted value. So in inserted you will see what new value has got inserted, and in deleted you will find what new old value was there. Let me just do it. So I am adding a new category out there. So now we have a record for new category, and automatically trigger happened, even the insert, and it has returned me that particular record. So if there are other columns also I would have got with that. And let me just do select star from categories. So now we have this category. Now what we'll do is we'll rename new category with, not with the future category. Okay, let's do with future category. So now when we are doing with future renaming this one, so the old value of the category name in the deleted will be new category, because now that value is getting deleted, and from inserted we'll get the new value. So we will see new value output and then the old value output. So if I'm doing it, so the new value is future category and the old value is new category. It's very simple. So with this one you can easily map. So let's assume you got a task where you have to do a data migration between tables and all, and someone says like all the affected values you should be capturing backup as well as the new values. So how you can do is you can use these magic tables to get that data. You don't have to write any logic for it. And if I delete it also, my delete one will run and I will get my deleted category. So I think, oh, I have renamed it this one with future category. So let me just delete it, and we'll see the future category row got deleted. If I go in my table, nothing is there. So you can back them up. So let me show you how you can back them up. So here I have created a temporary table variable. You can use temporary tables also. And what I'm saying, when the insert is happening, and this is happening in between values and insert keyword, I'm saying output inserted.id, inserted.customer ID and order date, and then insert that into this table variable, which I can use it later. It can be permanent table, it can be temporary table. You need not to have just this table variable. Okay. Now the similar way, when I'm doing delete, I can do the same thing. I think 11 was the one, or maybe 10. Let's say, let me just insert it again and we'll delete it again. So it is 12. So I will just go here and run it again. It will output from the deleted tables. Make sense? Same thing I can do with updates also. So in updates also you can add this. You can say output clause. Okay. Okay. Now coming back to the next, you can say our example. This is an, you can say, an stored procedure which has some kind of logic into it. Let's assume this logic is very big and there is some error happening in between, or some data is getting missed while insertion. Now how you will test it? Now what happens is people start looking at the stored procedure, its definition, and try to see, okay, what this might do and all. So the best and easiest way is make your SP executable. And how you do it? You comment the SP create statement, make it declare. Here. And also one more thing, let me just show you the output of this XP first. So this is nothing but it is applying customer ID, start date, and date kind of range of, and getting me the orders of that particular one and the total values of them. So both of that it is kind of fetching. Then what I'm doing is I am setting up all the parameter what I require to be passed, comment my as statement, and I run this stored procedure. Now without the stored procedure I made my query executable. And with that particular thing, what happens is if I have to troubleshoot, if something is missing in this one or the total is not matching, I can know, okay, here it's the step. I can fix my script. Once the script is fixed, I can go back to store procedure. And this small thing, you can use it on any size of SP, like it can be bigger one or smaller one. If they're interdependent SP, you can create some mock tables in between. But just by adding a declare statement and commenting out these things, you have made your SP executable script, which you can test, troubleshoot, and play around with. So the first thing is whenever you are debugging any big SP, make it executable, even the functions. So by this way, the troubleshooting increase, and that's why I'm saying this is essential. That's how we convert, you can say, a script, stored procedure into running script. Now coming toward the next favorite topic of mine, that is cross apply. Okay, so cross apply is very nice. You can say set of keywords we have, like, or you can say operators which help us to get the data. So here I'm saying select star from customer, let's say customer ID and company name, and then I'm saying cross apply, select count of total orders for that particular customer. And this is a correlated subquery. You all need to remember, if you are going for a developer interview, what is correlated subquery, where the outer query and inner query are dependent. So it says customer ID from the outer query should be on the where filter of customer ID of the inner query on the orders table and get the count for it. So I'm getting the count of each and every customer orders here. Now cross apply is, if I explain you, it is nothing but it execute the subquery for all the rows coming from the parent query. That is the only concept in the cross apply. Let me just show you a simple example. And cross apply need not to have a subquery which is referring to another table. It can just refer to within itself also. So here what I've done is, let's assume I want to print every company record 2 times. One is for morning shift and one is for evening shift for my reporting purpose. So I just created a small subquery which says morning and evening, and then I'm saying cross apply my customer with this particular output. And what it will do is for every company name it will generate 2 record, evening morning. I can sort them down in a different manner. You can do the same with the same table itself. Let me just give an example. So let's assume I have postal code and I have city. Now instead of like this, I want it to be like postal code, and I will say key, okay, as key, as value, and I will say postal code as key. And why I'm doing this one is so that I can pivot it when my transformation required to happen. So I will just say key comma value. Let me just comment this one out. What is there? Okay, I think square brackets, that should be enough. Yeah. So now I run this query, it will not run because this output is coming from the, you can say, the outer query, and this is a correlated subquery because it depends upon the parent. But here I'm not querying any other table. What I'm doing is I'm saying I want to split my every company row into 2 rows. One should denote the postal code, another should denote the city. Now let's assume you have to produce this spreadsheet kind of output. So here I will see, okay, for this customer postal code is this, and for city is this. And now this kind of setup is very good when it comes to you want to transform a pivot kind of or matrix kind of report, because once you have everything in 1 or 2 columns, you can easily tell, okay, pivot the column, so the column name will be key and the value will be the value what we are getting, so it can easily pivot it down. So the cross apply, what it do is it execute the subquery for every record given by the top query. So the whole thing is, if let's say you have 100 records in my table somewhere, I have explained that as well, But yeah, okay, give me a second. Okay, let's take an example. So let's say category has 3 records, each return and each returns 2 product matching in subquery. Means every category has 2, and from subquery, from the cross apply subquery, I am fetching the products. So I will get 6 records in total, 3 into 6. So because cross apply run the subquery for every row, means for 3 categories it is running the subquery 3 times, and every time it is getting 2 records, so it will produce 6 records. So cross apply do that. Now outer apply is similar to left, you can say left or outer joins, what we use. So let's assume here my customer doesn't have any data in the subquery. The subquery will not produce any output. Now to do that, to ensure like all the customers or all the records come, doesn't matter whether the subquery has any data or not, we should change it to outer apply. That's the only difference. It will provide you better result in that, because with cross apply generally we use either outer apply most of the time, but cross apply is very good when you know, okay, there will be never null. So this query will never be null, because every row has 2 columns, one is postal code and city, and which we are transforming into 2 different values, key and value pair, and this will always return. So there I can use a cross apply. Now you can also join the cross apply with recursive CTE. So first CTE, what I'm doing is I'm trying to get value from 1 to 10 for every row. If let's say my task is to produce 10 rows per customer, I need to produce, let's say, a form where someone fills the information. So here what I've done is I have multiplied every row with 10, you can say, values. This is also an interview questions. So how you can replicate the same, produce the same row 10 times. So you can just produce first 1 to 10 numbers with a cross apply, you can say recursive CT, and then just cross apply, and automatically that will work. The next topic is Dynamic SQL. Dynamic SQL in a very basic terms is it's running a query from a variable. That's that. So here if you say I am creating a table variable, and then the SQL, here I'm saying select star from, and the table name is coming from this variable, and then it is going into this SQL script, and then I'm executing. So if I run it, I will get my customers. Now if I change it to orders, I will get the orders. Now where the Dynamic SQL are used, most of the time any reporting like large reporting server, ETL server na, there are always big logics where you want to drill down the conditions. With Dynamic SQL you can put the condition and ensure not other conditions are like redundant conditions which might produce bad execution plan are required. You can do with the Dynamic SQL, and these are reality. People don't entertain like this one, but this is the reality. Without that it doesn't work. So here what I'm saying is this is my you can say column name country, and then this is Germany. If I run it, it is replacing my where filter, like where country name equal to parameter, and parameter is passed by this SQL one. So I'm passing the Germany. Here if I just say city Berlin, I want to get, so you can see I am changing the filters based on the Dynamic SQL. The reason why it is not entertained much is because it makes, you can say, execution plan caching problematic, because let's say if every time there is a parameter change by even space, it will not the parameter change. Let's say even someone just add a space out here, for us the output remains same because SQL treats the space as it is, but this query and without the space query are 2 different execution plan. So sometimes they are problematic in terms of execution plan, but they allows you to drill down the filters or the bottom level, or the, you can say, the least level. So it allows you to perform better. So execution plan caching can become the problem. Here if you see, I can even pass the column names. So this is order, so I will say order ID. So I can combine it like this. Here I'm just changing my even column list also based on this particular parameter. So the number of columns I'm fetching, the table I'm fetching from, the column by which I am to do order by, or everything is dynamic. So Dynamic SQL is very simple, but in the production you will find very big Dynamic SQL. At the end they are attaching 1 condition or 2 conditions, so and so on. So here I have just created a table also, Dynamic SQL. You can do it. If I run it again, it will throw an error saying the table already exists, and this is a permanent table we have created. So I can just drop this also. Now I don't require. Here this is a small example here. What I'm saying is, if my condition is pending, then add this condition ship date is null, it can be null. But if I am passing the condition shipped, then it should be not null. So if I run this particular query, and I can go into the message, it says select star from order 1 equal to 1. This is the default condition. And why this default condition? So that I can add and, because then it becomes the problem, because first condition should not have and in front of it, but all other. So by adding just 1 equal to 1, I am always ensuring I can add just and with it. So here it's saying ship date is null. Now I will change it to shipped, and automatically my SQL will change. And now if I go into my messages, it says ship date is not null. So this small example you will see on production on the large scale. That is the whole thing. So I hope this video has been informational for you, and I will have the follow-up video on performance tuning and all. These are the basic concepts. If you know how to write CTE, recursive CTE, and you can play around with cross apply, you can literally transform any kind of data. So if you have any question, you can let me know. Thank you. Have a good day. Bye bye.